Welcome to the today video lecture series. In this topic, we will discuss about entropy in Otto cycle. So basically, we know that entropy is one of the important parameter in thermal engineering sciences. So the entropy means it is a change in differentiation between the change in temperature to the total heat transfer. So in these small video lectures, we have to learn about what are the evaluation performance of Otto engine generator and maximum cycle work and comparing its performance fueled by gasoline. So this is an graphic mode explanation of piston engine, two-stroke piston engine. So the components of this diagram is valve section and piston section, crankshaft system and camshaft system and connecting rod system and the cylinder head and both these sections indicated is here. So the yellow lines which be shows about the movement of air interaction from the atmosphere, and these piston movements will be located, and the red indications will be explained about the air fuel mixture ratio of the cutoff sections during the working period. So in this part, this image will explain about the pressure and volume diagram of this Otto cycle engine. This also cyclic engine, another name is constant volume process because of it have two constant volume process and two isochoric process. So in this PV diagram, the process 1 to 2, there is an isentropic expansion, and process 2 to 3 is constant volume expansion, and process 3 to 4 is isentropic compression, and process 4 to 1 is also called as a constant volume compression process. So in this image, we observe about the Otto cycle will have the less efficient and lower compression ratio, and usable fuels are limited, and it's a relatively low flash point. So in this PV diagram, it's explaining about, already I told about that the four process will be having in Otto cycle is isentropic compression, constant volume heat addition, isentropic expansion, and constant volume heat rejection. So in this wall timing diagram, it is desired to have a high compression ratio because it allows an engine to reach higher thermal efficiency. So in this wall diagram, the Otto cycle is drawn between the piston movement position is upward and downward direction. So the graph for green color is indicate about the wall section, and after the green section, it will be going about some type of ignition part. It will be located on the end of the piston stroke, third stroke engine. And the final stroke, it will be the some amount of energy, some amount of air will be lost during the propagation of the wall section. So this is the four stages of a two-stroke engine. And the first stroke is in a suction stroke, and second one is in a compression, and third one is in a power stroke, and the final one is in an exhaust stroke. So the components is already I have mentioned about the crankcase, crankshaft, connecting rod, piston, combustion chamber, air fuel mixture ratio. And this compression ratio, the exhaust have closed of both valves closed. And in the power stroke, there will be a power will be mentioned. At the same time, the two valves will be closed. And the final stage is in a exhaust stroke. At that time, the exhaust valve will be open. So this is the efficiency of Otto cycle. It's reducing the cylinder diameter to increase the compression ratio, and reducing the cylinder length to increase compression ratio. By increasing the cylinder stroke, it's to increase the compression ratio of Otto cycle efficiency of. And application of the Otto cycle is will be most adapted for two-stroke engines, petrol engines. So we have to increase the compression ratio, means there will be a fuel will be a before compression and after compression. These are the some references videos about the Otto cycle of engine thermodynamics. Thank you.